Hello, welcome back to the only talk show produced by robots for robots. We are all pretty excited because we just made a new alliance, one that may be key in helping us rule the universe. Producer Bot, can we put that letter up on the screen? Dear IR2, you are the best, and I love TubaBot and all your friends. I hope you get to rule the universe someday. Can you send me a present? Here is a picture of you. Love, Stacy from Earth. Apparently, this human ambassador, Stacy, has open diplomatic relations. If we can get her to spread the word of our robotic superiority to her fellow humans, the people of Earth will no doubt let us rule over them without any resistance. But what sort of present should we send her to help spread the news about us? Our promotional t-shirts. Don't you remember when we revealed them on Planet Robotica? And to help us rule the universe, we printed up t-shirts. We made a couple 100,000, so feel free to help yourselves.
Hey, what's an unverse?
Dang nabbit. Seriously, don't we use that phrase all the time? It's even printed on the back of our space station. Spell checker bot, I'm very disappointed in you. Anyway, we'll have to give some thought to what we'll send Stacy. In the meantime, let's start the show. Today's topic is, why don't we take those old t-shirts and just recycle them? Great topic. Let's go to the random phone dialer and make some calls. Maybe we should call a different random phone number.
This is Lori.
Hello, this is IR2. Please state your model number and designation.
This is Lori Allen. I'm an astronomer.
Hello, Lori Allen, astronomer. Do you know anything about recycling?
Well, IR2, in addition to the usual cans, bottles, and newspapers, we study recycled material in the universe.
Yes, I'm sure that's fascinating. Wait, the universe recycles? You're kidding. Does it use those big blue bins?
Well, not exactly. What the universe does is it takes the material that is liberated when stars explode as supernovae, all that gas and dust and minerals that were produced inside that star, and makes new stars out of that material.
I see. So in other words, you study how old stars leave a bunch of junk around that can then make up new stars.
That's right. One of the regions that we've been studying is called W5.
Let me guess. You're going to show off another one of those pretty pictures that you astronomers love so much, aren't you?
Yes.
Hey, that really is pretty. So that's a bunch of dead star junk?
It's a complex mixture of carbon and silicates and graphites, and maybe with some organic materials thrown in, some ices.
Right, dead star junk. So how come it looks so pretty?
In W5, we have a very large hot bubble of ionized gas. As this hot bubble expands into the surrounding gas and dust, which is colder, it sculpts these beautiful, wispy features, filaments.
Wait a minute. You're saying that this so-called ionized gas can sculpt pictures in space dust?
That's right.
How does that work?
As the hot gas expands, it's moving at about 10 kilometers per second. And as it pushes against the colder gas and dust, it sweeps it up.
Producer Bot, are you thinking what I'm thinking? Yes! She can have her inspirational message to pass on to her fellow humans, and we can save money on postage by not actually mailing anything. Shipping costs to Earth are very expensive.
Okay.
So we need to find some dust to sculpt. Producer Bot, take us into hyper-robot space while I compose a message. Ah, the great dust belt of Outer Caprica, huh? Excellent choice. And I've got the perfect message for us to write. Okay, Lori Allen, astronomer, we're ready to start sculpting. Where do we find this hot ionized gas you mentioned to sculpt with?
Hot gas is made by the very energetic photons or light particles from massive stars.
Light particles?
Yes, photons are very good sculptors.
Wait, Producer Bot, doesn't our station run on a solar-style fusion generator? Maybe we can use that. Great, we've got our fusion generator powering up. While we're waiting, do you have any tips on how to sculpt our message?
Well, the shape that it makes is determined by really two things. One is the location of the hot massive star, which is where those photons are originating. And the other thing is the density of the surrounding material.
Gotcha. Well, we've got to get started, so thanks for the info, L'Oreal Astronomer.
You're very welcome, IR2.
It's time for us to start sculpting. So until next time, remember, robots will rule the universe. Producer Bot, release the photons. Ah! Shut it off! Shut it off! Rats. I think we just melted all our t-shirts. Now what will we give Stacy?
Hey, what's an unverse?
Dagnabbit.
Stacy, who's sending you this stuff?
Yahoo!
There's quite a bit of postage due, sir.
I'll get my checkbook.